What if I told you that in a survival situation, you could have a flying companion watching your back 24/7? A drone that scouts ahead for dangers, locates water sources, and even delivers emergency supplies when you need them most. Today, we're going to build exactly that, a survival companion drone that could literally save your life in the wilderness. Now, I know what you're thinking. Building a drone sounds complicated, maybe even impossible if you're not a tech expert. But here's the truth. With the right guidance and a few accessible components, anyone can build a basic survival drone. And that's exactly what we're going to do together in this video. Before we dive into the build, I want to mention something cool for all you survival enthusiasts out there. We've put together an incredible ebook. It's actually a Gamma Roach comic book that explores survival scenarios in a really unique, engaging way. If you're into survival stories and want some entertaining reading material for your downtime, definitely check the link in the description to download our ebook. Trust me, it's worth a look. Also, if you're serious about the survival lifestyle, we've got some awesome merch that's both practical and shows your commitment to preparedness. Check the link in the description to check out our merch. We've got gear that actually holds up in real situations. Alright, let's get into this build. By the end of this video, you'll understand exactly how to construct a drone that can be your eyes in the sky when you're out in the wild. Think about the most dangerous moments in survival situations. It's usually when you don't know what's around the next corner. Is that a water source or a bog that'll swallow you whole? Is there a bear den in that cave you were planning to shelter in? Can you find your way back to camp before nightfall? A companion drone solves these problems. It gives you aerial reconnaissance without putting yourself at risk. You can scout terrain, locate resources, check on signal fires, and even use it to signal rescue teams with its lights and movement. In survival situations, information is survival, and a drone gives you information from perspectives you could never achieve on foot. The drone we're building today is designed specifically for survival scenarios. It's durable, relatively simple to repair in the field, and uses components that won't break the bank. Most importantly, it's practical. This isn't some high-tech fantasy. It's a real tool you can build and deploy. Let's talk about what you'll need to gather for this build. Don't worry, I'll keep this practical and accessible. First, you'll need a basic drone frame kit. Look for something in the 250 to 300 millimeter range. That's the diagonal distance between motors. This size gives you a good balance between portability and stability in wind. You can find these frames online for around $30 to $50. Go for something made of carbon fiber or tough plastic that can handle a crash. Next, you'll need 4 brushless motors. For a survival drone, I recommend 1000 to 1400 kV motors. These provide enough power for carrying small payloads without draining your battery too fast. You'll need 4 electronic speed controllers, or ESCs. These regulate power to your motors. Get 30 amp ESCs to match your motor specs. The brain of your operation is the flight controller. For beginners, I highly recommend something like an SP Racing F3 or similar. These are affordable, around $20 to $40, and they come with stabilization features that make flying much easier. You'll need a radio transmitter and receiver. This is how you'll control your drone. A basic 6-channel transmitter will do the job perfectly. Expect to spend around $50 to $80 here. Power comes from lithium polymer batteries, or LiPos. Get a 3 or 4 cell battery with at least 2000 mAh. You'll want at least 2 batteries so you have a backup. Don't forget for propellers that match your motor size. A power distribution board to split power from the battery to all 4 ESCs and various connectors and wires. For survival-specific additions, grab a small FPV camera and video transmitter if you want first-person view capability. This lets you see what the drone sees in real time. Also consider adding a small LED strip for night visibility and a GPS module for return-to-home functionality. Total cost for everything. You're looking at around $200 to $400, depending on the features you choose. Yes, it's an investment, but compare that to the value of your life in a survival situation. You won't need a full workshop, but having the right tools makes this build go smoothly. Get yourself a decent soldering iron and solder. Most of your connections will be soldered for reliability. Grab some wire strippers and cutters. You'll need a set of small hex wrenches for assembling the framemost frames. Come with the sizes you need. Have some zip ties on hand for cable management, and get some heat shrink tubing to protect your solder connections. A multimeter is incredibly useful for checking connections and diagnosing problems. And finally, a small screwdriver set will help with various assembly tasks. If you don't have these tools, don't panic. This is a great opportunity to build a basic toolkit that'll serve you for years in other projects too. Let's start building. The frame is your foundation, so take your time here, unpack your frame kit, and lay out all the pieces. You should have 4 arms, a main body plate, and a top plate, plus various screws and standoffs. Start by attaching the 4 arms to the main body plate. Most frames have the arms slotting into the center and being secured with screws from underneath. Make sure each arm is firmly attached. These will take the stress of flight and any hard landings. Once the arms are secure, place your power distribution board in the center of the main plate. This usually sits right in the middle, where it can connect to all 4 ESCs easily. Some frames have mounting holes specifically for the PDB. Others you might need to secure with double-sided tape or zip ties. Now attach the top plate. This sandwiches everything together and usually provides mounting space for your flight controller. Use the standoffs that came with your kit to create space between the top and bottom plates. This gives you room for wiring and components. Take a step back and make sure everything is square and tight. A loose frame will cause vibrations in flight, which confuses your flight controller and makes the drone unstable. Time to give your drone the ability to fly. Each motor mounts to the end of an arm. Motors typically mount with 4 small screws that go through the motor mounting holes into threaded holes on the frame arms. Make sure your motors are mounted firmly. A motor that comes loose in flight is catastrophic. Here's a critical detail: motor rotation direction. 2 of your motors will spin clockwise, 2 will spin counterclockwise. This is how multi-rotors maintain stability. Usually, you'll have clockwise motors on opposite corners and counterclockwise on the other opposite corners. Check your flight controller documentation for the correct pattern. Now mount your ESCs. These can go on top of the arms or underneath, whatever works for your frame design. Many builders use zip ties to secure ESCs to the arms. Make sure they're not dangling loose, but also not so tight that you're crushing components. Connect each ESC to its corresponding motor. ESCs have 3 wires that connect to 3 wires coming from the motor. The order of these connections determines spin direction. If you connect them one way and the motor spins the wrong direction later, you can simply swap any 2 of the 3 wires to reverse it. Power distribution is where many beginners get intimidated, but we'll take it slow. Your battery connects to the power distribution board. Most PDBs have thick pads marked positive and negative where you'll solder your battery connector. If your battery has an XT60 connector, solder that directly to the PDB. Make sure positive goes to positive and negative to negative reversing. This destroys components instantly. Now, each of your 4 ESCs needs power from the PDB. ESCs have a thick red wire for positive and thick black wire for negative. Solder these to the corresponding pads on the PDB. Most PDBs have 4 sets of pads, 1 for each arm. Use heat shrink tubing over every solder connection you make. This prevents short circuits and protects your connections from moisture and vibration. This is also a good time to add any voltage regulator or battery monitor you're using. Many flight controllers need 5 volts, and you'll step down your battery's voltage using a regulator that connects to the PDB. Double-check every connection with your multimeter before proceeding. A short circuit with a LiPo battery is dangerous. The flight controller is the brain that keeps everything stable. Mount your flight controller on the top plate using the soft mounting grommets or foam that came with it. This is important hard mounting. The FC directly to the frame transmits vibrations that throw off its sensors. The arrow on the flight controller should point toward the front of your drone. Now connect your ESCs to the flight controller. Each ESC has a signal wire, usually white or yellow, that plugs into a motor output on the FC. Connect them in order: motor 1, motor 2, motor 3, motor 4, following your FC's layout. Connect your receiver to the flight controller. This usually involves plugging the receiver's output channels into the FC's receiver input. Different FCs and receivers have different protocols, so consult your specific documentation here. If you're adding GPS, camera, or other accessories, connect them to the appropriate ports on your FC now. Power everything up for the first time by plugging in your battery. You should see lights on the flight controller indicating its receiving power. If you smell burning or see smoke, disconnect immediately and check for shorts. The flight controller needs to be configured via software on your computer. Download the configuration software for your specific FC most use, Betaflight or similar. Connect your FC to your computer via USB and follow the setup wizard. You'll calibrate sensors, set up your receiver, configure motor outputs, and set flight modes. This configuration step is crucial. Take your time, follow tutorials specific to your flight controller, and don't skip the accelerometer calibration. Now, let's make this a true survival companion. First, add a GPS module if you haven't already. This enables return-to-home functionality if you lose signal or the battery gets low. The drone automatically flies back to its takeoff point. In a survival situation, losing your drone is losing a critical tool, so this feature is invaluable. Install your FPV camera on the front of the drone. Most frames have mounting solutions for cameras. Connect the camera to your video transmitter, which sends the video signal to goggles or a screen you're wearing or holding. Being able to see what the drone sees dramatically increases its usefulness for scouting. Add LED strips for night visibility. Wire these to a spare output on your flight controller so you can control them with a switch on your transmitter. Bright lights help you maintain visual orientation and can be used for signaling. Consider adding a small payload bay or mounting point. A survival drone should be able to carry small items, fire starting kit, emergency note, first aid supplies. Even 50 to 100 grams of payload capacity can be life-saving. Weatherproofing is important. Use conformal coating spray on your electronics to protect against moisture. Make sure all openings have some protection from water ingress. Never skip this step. Testing saves crashes, and crashes in survival situations mean you're without your companion. Start by testing on your bench with propellers off, plug in your battery, and use your transmitter to slowly increase throttle. All 4 motors should spin up smoothly and at the same rate. If one motor doesn't spin or spins at a different speed, troubleshoot before proceeding. Check that your control inputs are correct. Moving the pitch stick forward should speed up the rear motors. Moving it backward should speed up the front motors. Roll and yaw should respond correctly to. If anything is reversed, fix it in your FC configuration software. Now it's time for your first flight, and I cannot stress this enough. Do this in a large open area away from people and obstacles. Remove any expensive additions like cameras for this first flight. Install your propellers, making sure each is on the correct motor. Clockwise props on clockwise motors, counterclockwise props on counterclockwise motors. This is usually indicated on the propeller itself. Start with the drone on level ground. Arm your drone. This is usually done with a stick combination on your transmitter. Slowly increase throttle until the drone is hovering about waist height. It should feel relatively stable. If it's tilting or spinning uncontrollably, land immediately and recheck your configuration. Practice basic movements: forward, backward, left, right, up, down, and rotation. Get comfortable with how it responds. This takes time, and crashing is part of learning, which is why you practice in safe areas first. As you gain confidence, test your survival features. Fly the drone away and activate return to home. Watch it come back automatically. Test your FPV system if installed. Practice flying beyond visual range using the FPV feed. Let's talk about actually using this drone when it matters. Battery management is critical. In survival situations, you won't have easy recharging. Bring multiple charged batteries and a solar charging solution if possible. Never fly your battery below 20% LEPOs. Damaged by over-discharge are useless. Use your drone strategically, not constantly. Scout ahead before moving camp, check water sources before approaching, and survey terrain to plan routes. Each flight should have a purpose to conserve battery life. Mark your takeoff point clearly every time you launch. GPS return to home is great, but if that fails, you need visual markers to guide the drone back. Practice emergency procedures. What do you do if you lose signal? If the battery dies mid-flight? If a motor fails? Knowing these scenarios prevents panic when they happen for real. In survival situations, your drone is a tool, not a toy. Treat it with the respect you'd give any life-saving equipment. Let's be serious about safety for a moment. Propellers spin at incredibly high speeds and can cause serious injury. Never reach toward a drone with spinning propellers. Always disarm before approaching. LiPo batteries are powerful but dangerous if mistreated. Never puncture them, never charge them unattended, and store them at storage voltage when not in use. A LiPo fire is intense and hard to extinguish. Respect local regulations about drone flight. Even in survival situations, understanding the rules beforehand prevents legal trouble later, whether matters. High winds make drones difficult to control and drain batteries fast. Rain can destroy electronics despite weatherproofing. Know your limits and the drone's limits. Signal interference is real. Mountains, trees, and other obstacles block radio signals. Always maintain line of sight when possible, and understand that your range in dense wilderness is much less than in open areas. Your drone will need care to stay functional. After every flight, inspect it. Check for loose screws, damaged propellers, or frayed wires. Tighten what's loose and replace what's damaged immediately. Carry spare propellers. They're lightweight and they break easily. Bring extra zip ties for quick frame repairs. A small soldering kit lets you fix broken connections in the field. Keep your drone clean. Dirt in motors causes them to fail. Wipe down the frame and electronics after flights in dusty conditions. Store the drone properly. Remove the battery for storage and keep everything in a protective case. Moisture is your enemy, so silica gel packets in your storage case help. Learn basic troubleshooting. If a motor stops working, check the connections before assuming the motor is dead. If the flight controller acts strange, recalibrate the sensors. Most problems have simple solutions if you think systematically. And there you have Itura Complete Guide to building a companion drone that could genuinely save your life in survival situations. We've covered everything from selecting components to assembly, from initial testing to field use, and from safety to maintenance. This isn't just a project, it's a skill. You've learned electronics, you've learned flight principles, and you've learned to think about tools strategically. These skills extend far beyond this one drone. Remember, the first drone you build might not be perfect, and that's okay. Each build teaches you more. Each flight makes you a better pilot. Each time you troubleshoot a problem, you're becoming more self-reliant. The key to survival isn't having one tool that does everything. It's having skills and adaptable tools you understand deeply. This drone is exactly that. You built it, you understand how it works, and you can repair it because you know every component. If you haven't already, go check out that Gamma Roach ebook I mentioned earlier. It's linked in the description, and it's a fantastic companion to this kind of practical survival content. And for those of you getting serious about this lifestyle, our merch is designed for people who actually use their gear, not just collect it. Thank you for joining me on this build. If you found this video helpful, hit that like button and subscribe for more practical survival content. Drop a comment below telling me what survival project you want to tackle next. I read every single one. Stay prepared, stay safe, and remember, in survival situations, information is life, and now you have eyes in the sky. Until next time, this is your guide to building not just drones, but the skills that matter when everything else fails.